You're looking at walls that shouldn't exist. 12,000 feet up in the Peruvian Andes, stones weighing 200 tons sit locked together without mortar, cut so precisely that a razor blade won't fit between them. No iron tools, no wheels, no written plans. The Spanish found them in 1533 and immediately started tearing the complex apart to build churches. What they couldn't move, the biggest blocks, the ones that defied every explanation, those stayed. Those are what you see today at Sacsayhuamán. Scientists have been studying this site since the 1800s, throwing theory after theory at these walls, and still, 12 fundamental mysteries remain unsolved. These aren't legends. These are documented problems that modern engineering cannot answer. 12 cases where the facts stopped making sense. The Inca themselves said it started under Pachacuti in the 1400s and took 3 generations to complete. Carbon-14 dating done on the site shows Quilque culture occupation around 1100 CE, centuries before the Inca arrived. So who built what? The main terrace walls stretch 400 meters long and originally stood 18 meters high before the Spanish demolished the upper sections. The estimated volume of remaining stone exceeds 6,000 cubic meters. Some individual blocks range from 128 tons to nearly 200 tons according to measurements published in Wikipedia's engineering analysis, last updated in December 2025. The walls zigzag in 3 massive terraces, each stone irregularly shaped with up to 12 angles fitting together like a 3-dimensional jigsaw puzzle. Not one drop of mortar, and they've survived 5 centuries of earthquakes that flattened colonial buildings in Cusco below. Wikipedia cites this distance as 22 miles. Some limestone came from sources 9 kilometers away. Andesite blocks were quarried from nearby diorite deposits. But here's the issue. A 200-ton block is 400,000 pounds. 400,000. Let that number sit. Modern heavy-haul trucks max out around 80 tons. A Caterpillar 797 mining truck, one of the largest production trucks on Earth, has a payload capacity of 400 tons, but weighs 363 tons empty and requires paved roads. The Inca had no wheels, no draft animals strong enough to pull that weight, and the route from Rumicolca crosses the Huatanay River Valley and climbs back up steep Andean slopes to 3,700 meters elevation. The terrain is not flat. The grade, in some sections, exceeds 15%. Archaeologist Roseanne Chambers, writing in August 2024 on her research blog, describes finding hammerstones and evidence of nibbling at quarry sites. Workers literally pecking away at rock bit by bit to shape blocks. At Rumicolca, you can still see partially finished blocks abandoned in varying stages of production. The quarry is still worked today with modern equipment. Tests show you can move surprisingly large stones with enough people, wooden rollers, and rope. A controlled experiment documented by multiple researchers showed that coordinated teams of hundreds of workers using ropes and rollers can move 20-ton blocks. 40 tons is theoretically possible with perfect coordination, favorable terrain, and stronger rope than anything documented from the Inca period. But 200 tons? The physics don't add up. Show me the rope, made from llama wool or plant fiber, that doesn't snap under 400,000 pounds of tension. Modern synthetic rope, rated for heavy lifting, uses aramid fibers with tensile strength around 500,000 psi. Natural fiber rope maxes out at maybe 30,000 psi for the best materials. You'd need cable thickness measured in feet, not inches. And at that thickness, the rope becomes too stiff to wind around any manageable pulley or roller system. The mechanical advantage needed to move 200 tons up a 15% grade requires either gear reduction that the Inca demonstrably didn't have, or workforce numbers that exceed the 20,000 cited by chroniclers by an order of magnitude. A 2024 study by Alexei Vranich at the site in summer used ground-penetrating radar in trenches at Muyuk Marca and the Bastion bases. He told Instagram followers the big question remains how they moved these stones. The excavations found evidence of construction phases, but no evidence of the transport mechanism itself. No preserved rollers, no rope fragments, no ramp foundations capable of supporting the loads required. 60 years of controlled experiments by engineers and archaeologists haven't replicated moving a block this size across that terrain using Inca-era materials. Jean-Pierre Pratzen, whose work remains the gold standard for Inca quarrying research, focused primarily on cutting and shaping techniques. He never claimed to solve transport at this scale. Transport remains unsolved, not theoretically difficult, unsolved. The cutting precision. Walk up to the walls today and you'll see stones with surfaces so smooth they reflect light. The joints between blocks are tighter than a sheet of paper. Multiple sources confirm that even a razor blade won't fit. Some contact surfaces run three-dimensional, meaning they curve and angle in multiple planes simultaneously. Not flat surfaces meeting at angles, complex curving surfaces that somehow match each other perfectly. To achieve this, you need to know the exact shape of the neighboring stone before you cut. But the neighboring stone is already in the wall, locked in position by the stones around it. So you're cutting stone number 47, to fit perfectly against stones 45 and 46, which are fixed in place and cannot be moved for test fitting without dismantling half the wall. Jean-Pierre Protzen spent decades studying Inca masonry and published his findings on the technique. He proved you can achieve tight fits by pecking with harder stone hammers, then rubbing surfaces together with sand as an abrasive. His replications, documented in multiple papers and shown in a video demonstration available through his published research, show this works for smaller blocks. Pecking creates a rough shape. Then the abrasive rubbing produces precision fit. For blocks under 1 ton, he demonstrated the process works. The fit quality matches what you see in Inca walls made from smaller stones, but the math changes dramatically at scale. A 200-ton stone cannot be lifted repeatedly for test fitting. Each lift requires massive infrastructure. Think about the process. You rough shape the stone at the quarry. You transport it to the site, already a miracle. You position it next to the stones it needs to fit against. You test the fit. It's not perfect. So you lift the 200-ton block again, move it aside, make adjustments, reposition it, test again. How many iterations? Protzen's smaller blocks sometimes required 10 or 15 positioning cycles to achieve perfection. Each cycle for a 200-ton block means building and dismantling scaffolding, rigging, and support systems. The labor and time investment becomes absurd. So either they got it perfect on the first placement, which strains belief given the complexity of 3-dimensional curved joints, or they had a method we haven't identified that allowed them to shape the stone to precision while it was in final position. A December 2025 article on ancient stonework from Splash Travels describes how recent petrographic analysis revealed the builders selected geologically altered limestone with specific crystal structures that respond predictably to shaping tools. The microscopic analysis showed recrystallized calcite and distinctive microfractures, suggesting the material underwent natural alteration before extraction, under elevated pressure or temperature. The stone's natural fracture lines helped achieve precision because it split cleanly along predictable planes. The consistent grain size meant tools remove material uniformly. That's significant. It shows material science knowledge. They understood rock properties at a level that let them select stones that would behave consistently under their tools. But that still doesn't explain 3-dimensional curved joints on blocks this massive. Even with ideal stone properties, you cannot carve a complex 3-dimensional concave surface on a 200-ton block and expect it to mate perfectly with the convex surface of its neighbor without test fitting. The geometry requires feedback, iteration, measurement, and at this scale, iteration becomes mechanically and logistically impossible. The precision at scale remains unexplained, not just impressive, unexplained. The extraction technique, as noted in an above top secret forum discussion analyzing quarry evidence, left rounded corners and cliff faces where stones were removed, almost machined edges. Partially finished blocks along transport routes show progressive refinement, but not failure. Not mistakes that would indicate they were figuring this out as they went. It's as if the technique was already perfected when they started, or the failed attempts were completely erased. The level of execution suggests either an extremely long period of development we haven't found evidence for, or knowledge transferred from somewhere else. No intermediate stages, just sudden mastery. This script is researched and factual, using sources from ArchaeoNews published March 14, 2025, the Further Travel Archaeology blog updated September 21, 2024, peer-reviewed studies from Science Direct, published March 29, 2024, on seismic analysis using finite element modeling, and ground-penetrating radar findings from the 2025 Chincana project, led by archaeologists Jorge Calero and Mildred Fernandez. These aren't clickbait sources. These are field reports from active excavations and structural engineering journals. Now back to the information. The 1970 Peru earthquake registered magnitude 7.9 and killed 70,000 people. The 2007 Pisco earthquake was magnitude 8.0. Cusco has been hit by major seismic events throughout recorded history. Colonial buildings collapsed. Modern concrete structures designed with seismic codes cracked and failed. Sacsayhuamán's walls shifted slightly and settled back into place. Not just once. Repeatedly, 5 centuries of earthquakes. The analysis calculated the structure's predominant frequencies using white noise and sinusoidal signal inputs. Then they ran nonlinear dynamic analysis using 3 recorded Peruvian seismic events. The results showed the structure could suffer significant damage at peak ground accelerations greater than 0.2 G, which corresponds to magnitude 6.5 to 7 earthquakes. But here's the key finding. The interlocking design allows stones to move independently during seismic waves, absorbing and dissipating energy through controlled micro-movements, then resettling without catastrophic failure. The walls don't resist the earthquake. They dance with it. Earthquake engineering. This inward inclination isn't random, it's calculated. When seismic waves cause lateral ground motion, the inward lean means the wall's center of gravity remains inside its base even as the structure sways. The angle counteracts overturning moments. Each stone's irregular, polygonal shape creates multiple contact points, often 5 to 12 angles per stone. This distributes stress across different planes rather than concentrating force at a few points. When the ground shakes, energy dissipates through micro-movements at these multiple contact surfaces. The friction at each interface damps vibration. The whole wall acts as a mechanical damper. Prevent resonance buildup. Japan's earthquake-resistant buildings use base isolators with sophisticated rubber and steel bearings. The Inca built it in stone 500 years ago without computer modeling, without accelerometers, without any way to measure ground motion quantitatively, frequencies that cause failure and material behavior under dynamic loads. You need to understand that buildings can fail not just from peak acceleration, but from resonance. When the building's natural frequency matches the earthquake's dominant frequency, oscillations amplify and the structure tears itself apart. Modern engineers calculate this using differential equations, dynamic analysis software, and scale models tested on shake tables. The Inca had empirical observation and trial and error, but trial and error with structures this large means failure results in total loss. You don't get to experiment with 200-ton blocks. The stakes are too high, the investment too massive. And Tipon. Archaeologists can see the damage in the walls, openings between rocks, edges broken where stones hit each other during ground motion. After that earthquake, Inca construction changed dramatically. They abandoned smaller cellular masonry assembled from stones under 1 ton and developed the massive trapezoidal structures with huge base stones we see today. They learned from the earthquake. The post-1450 construction shows understanding of seismic resistance that the pre-earthquake structures lacked. Without stress calculations, without knowledge of Young's modulus or shear strength or damping coefficients, they went from seeing earthquake damage to implementing the inward-leaning, multi-contact point, energy-dissipating wall design that modern engineers recognize as sophisticated seismic engineering. That's not trial and error. That's systematic understanding applied to structural design. The seismic adaptation remains unexplained. Not just the resistance itself, but the knowledge transfer from observation to implementation. Ancient Pages reported this in March 2020 on their examination of advanced ancient technology theories. The claim is that some method, unknown technology, focused solar energy, chemical process, melted the stone surface to achieve the glassy finish seen on certain blocks. David Hatcher Childress wrote about this in his book Ancient Technology in Peru and Bolivia, noting that several Cusco area sites, including Sacsayhuamán and Kenco, showed what appeared to be vitrified surfaces. The problem? Mainstream geology has provided an alternative explanation. The December 2025 Splash Travels article on geological analysis describes how petrographic imaging revealed the limestone underwent natural recrystallization under elevated pressure or temperature deep underground before extraction. The altered crystal structure gives it unusual properties. It cuts cleanly, holds sharp edges, and has a naturally smooth texture when polished. So the glassy appearance could be geological, not technological. But here's where it gets murky. Some stones do show characteristics inconsistent with natural alteration. Some surfaces appear melted or molded rather than carved. A World Mysteries blog, examining Cyclopean walls, notes that certain features look poured or pressed into shape. The debate remains open because we lack comprehensive chemical analysis of enough samples. The vitrification question is unresolved. 10 minutes later, the rock surface was soft as wet cement. Fawcett described the plant as having dark reddish leaves, about a foot high, possibly found near the Pyrenee River in Peru's Chuncho country. Another account tells of a biologist watching a bird rub a twig against a rock face. The sap dissolved the stone, creating a hollow for a nest. In 1983, Catholic priest Jorge Lira claimed he reproduced a stone softening technique, using plant extracts, but couldn't reverse it to make the stone hard again. These stories circulate widely. Ancient Code published an analysis in July 2016 examining whether ancient cultures had access to chemical agents that could temporarily soften stone, place blocks like pressing together plasticine, achieving perfect fits through compression rather than carving. The heavier the block, the better the fit as the softened surfaces squeeze together and later harden. The theory would explain several otherwise inexplicable features: joints that appear molded, lack of tool marks in certain areas, bulging at joint lines that resembles material pressed together. The scientific community dismisses this as folklore because no one has demonstrated the process reliably. No chemical analysis of Sacsayhuamán stones has found residue of organic compounds that could soften silicate minerals, but absence of evidence after 500 years of weathering doesn't prove it didn't happen. Colonial era accounts mention the technique repeatedly. Spanish chroniclers wrote that indigenous people spoke of methods involving plants. If it's pure legend, why did multiple independent sources report the same thing? The stone softening question remains open. Pour this into molds, let it cure, and you get stone-like material that can be cast to precise shapes. French materials scientist Joseph Davidovits has argued that certain ancient Egyptian pyramid blocks were cast geopolymers, not carved limestone. The same argument has been applied to Sacsayhuamán. If you're pouring material into forms rather than moving solid blocks, the transport problem disappears. The precision problem disappears. Molds create exact shapes. The lack of failed attempts makes sense. You're manufacturing, not quarrying. Some researchers claim to have found evidence supporting this. Air bubbles in stone that shouldn't be there. Organic material inclusions, chemical composition, slightly different from natural limestone. The issue is that mainstream geological analysis, like the December 2025 Splash Travels petrography study, consistently identifies the stone as natural limestone that underwent metamorphic alteration, not artificial. The geopolymer camp argues that ancient geopolymers would be chemically indistinguishable from natural stone after centuries of curing and weathering, which means the debate can't be settled by standard chemical tests. You'd need to find unmistakable manufacturing evidence, mold marks, mixing artifacts, compositional. Gradients inconsistent with geological formation. So far, no one has published conclusive proof either way. The geopolymer theory remains speculative but not disproven, 150 meters through the heart of the city. An anonymous Jesuit chronicler in 1600 described a deep cave that connected Sacsayhuamán to the Coricancha, passing beneath the entire city of Cusco. The account is detailed, describing the tunnel entering near Sacsayhuamán's Rodadero sector, running beneath what is now the historic center. Ephraim George Squire, American diplomat and amateur archaeologist, wrote in his 1867 travelogue that General Sacsayhuamán had sections of the tunnels walled up in 1841 after 3 boys got lost inside and starved to death in the recesses. That account gives specific dates and names. For decades, academic archaeology treated this as legend, folklore, colonial exaggeration. Then in January 2025, archaeologists Jorge Calero Flores and Mildred Fernandez Palomino announced confirmed discovery of the tunnel system using ground-penetrating radar and acoustic prospecting. Their team operated as part of the Chincana Sacsayhuamán project, using technology that can map underground voids by measuring how radar waves and sound waves reflect off different materials. The Smithsonian Magazine reported on January 21, 2025, that the team successfully mapped a main tunnel at depths of 1.4 to 2.5 meters below current ground level. The tunnel measures approximately 2.6 meters wide and just over 1.5 meters tall, dimensions comfortable enough for people to walk through but not wastefully large. The main passage runs 1,750 meters from Sacsayhuamán toward Coricancha, with 3 documented branches. One branch leads to Muyuk Marxa, the circular tower complex. Another runs behind the church of San Cristobal. The third stretches through the Muyuk Marxa sector of Sacsayhuamán itself, possibly connecting to deeper levels. March and April 2025 would physically access sections of the tunnel to document construction methods, materials, and dimensions. According to America Television's Quarto Poder, broadcast on October 1st, 2025, the tunnel system may extend over 8,000 meters when all branches are fully mapped. That's 8 kilometers of underground passages. For scale, the Paris catacombs span about 280 kilometers, but they're natural limestone quarries adapted for burial. 8 kilometers of purpose-built tunnel underneath a city at 3,700 meters elevation represents massive engineering. Chincana Chica is open to tourists for about 15 meters before the passage narrows to a crawl space that continues deeper. Recent photographs from 2025 excavations show the entrance marked by a carved serpent head in stone, exactly matching descriptions from Spanish chronicler Martín de Murúa in the 1600s. Chincana Grande remains restricted for safety, with archaeological work ongoing at the entrance sector. The entrance sits in a rocky outcrop, stone-lined and reinforced with wooden beams according to colonial descriptions. Cold air flows out of the entrance. Cavers and tunnel explorers know this indicates extensive void space deeper in, connected to the surface through multiple points, creating air circulation. If there are ceremonial passages connecting sacred sites, why do they need structural reinforcement with wooden beams? That's utilitarian, not symbolic. If there are defensive escape routes for when the fortress falls under siege, why are they so elaborate? Why 3 main branches? Why 8 kilometers? A simple escape tunnel needs 1 route out, maybe 200 meters, to beyond the siege perimeter. If there are communication routes allowing movement between sites during ceremonies, why run them so deep underground? Surface pathways would be easier. The tunnel's function remains unexplained until full exploration occurs. Spanish accounts from the 1536 siege of Cusco never mention the defenders using tunnels to move troops or supplies, suggesting either the Spanish didn't know about them or the tunnel served purposes the Spanish couldn't perceive or understand. Religious passages, storage access, acoustic chambers for ritual, water management infrastructure, all possibilities, none proven. The tunnels exist. Their purpose remains unknown. Inca Garcilaso de la Vega described it in his royal commentaries as serving as a water reservoir connected to other towers by the underground tunnels, but analysis of the site's orientation raises questions. Archaeological excavations published in Archaeonews March 14, 2025, and research documented in Ancient Rix in August 2024 show that major structures at Sacsayhuamán align with solstice sunrise and sunset points. The zigzag walls run perpendicular to the June solstice sunset. The Muyucmarca Foundation aligns with December solstice sunrise. A Mixteco article from March 3, 2024, examining Inca calendar systems notes that Sacsayhuamán, like other major Inca sites, demonstrates purposeful alignments with celestial events critical to their agricultural calendar. Inca astronomer priests use shadow measurements, horizon alignments, and systematic multi-generation observations to track solar, lunar, and stellar cycles, with precision rivaling pre-telescope European astronomy. What's unexplained is the level of accuracy achieved without optical instruments. The primary axis of some features aligns with true north to within 3 degrees of arc. Machu Picchu's Intihuatana stone, measured with modern GPS, shows this precision. 3 degrees is what you'd expect from trained surveyors with theodolites. The Inca used bronze tools, plumb lines, and naked eye observation. How they corrected for atmospheric refraction, annual precession, and magnetic variation without mathematical tables is unclear. The astronomical precision exceeds what should be possible with their documented tools. Pedro Cieza de Leon's 1553 chronicle says 20,000 workers built Sacsayhuamán, 4,000 quarried stone, 6,000 transported it, the rest prepared sites and cut timber. The work proceeded in shifts. When workers grew tired, fresh crews replaced them. No one labored continuously. The system prevented exhaustion but required massive coordination. We're talking about feeding, housing, and organizing 20,000 people at 3,700 meters elevation. That's a small city. Where are the worker camps? Where's the infrastructure for that operation? Archaeological surveys at Sacsayhuamán found ceremonial structures, military storage facilities, residential platforms, but not the scale of domestic sites needed for 20,000 laborers plus support population. Spanish chroniclers described seeing extensive facilities, but much was demolished for building material. Modern excavations, directed by Vranich in 2024, found some evidence of work camps in the Cruzmoco sector, but nothing approaching the capacity required. Inca labor organization ran on the Maita system, rotational public service where communities contributed labor as tax. But managing 20,000 people on rotation, maintaining construction continuity as crews changed, ensuring quality control across shifts, that requires administrative sophistication we don't fully see in the archaeological record. The logistics capacity remains a mystery. Muyucmarca was circular, the other two rectangular. All three were connected by underground tunnels. During the 1536 battle when Manco Inca besieged Spanish-held Cusco, Inca warrior Cahuid threw himself from Muyucmarca rather than surrender. The Spanish demolished all 3 towers after the siege, using the stone for construction in Cusco. Today, only the Muyucmarca Foundation remains visible. Concentric terraces forming a stepped pyramid structure. What were these towers? Garcilaso says Muyucmarca stored water, connected by underground channels. But archaeological analysis suggests ceremonial function. The circular design is rare in Inca architecture. Most structures are rectangular. Circular buildings usually mark sacred sites. A Peruvian Sunrise article notes that some researchers believe Muyucmarca was a solar temple, its shape mirroring astronomical observations. The foundation's orientation supports this. It aligns with solstice events. But if it's a temple, why does Garcilaso describe it as a water reservoir? Were both true? Did it serve dual functions? The tower's exact purpose and why they required tunnel connections has never been determined. The Spanish destroyed the evidence. What remains are foundations and colonial accounts that contradict each other. The Quilque were a regional culture that predated the Inca Empire. When the Inca expanded in the 1400s, they occupied and modified existing Quilque sites. So did the Quilque build the megalithic walls? Or did they build smaller structures that the Inca later expanded? Brian Forster wrote in Lost Ancient Technology of Peru and Bolivia that if excavations went deeper than current levels, they might find evidence of even earlier cultures. Some of the largest blocks show no signs of Inca finishing techniques, no peck marks, no evidence of the bronze tools Inca are known to have used. The masonry style varies across the site. Lower courses use massive, irregularly shaped blocks, the Cyclopean style that defies explanation. Upper courses, mostly demolished by Spanish, used smaller rectangular stones, consistent with known Inca construction techniques. This suggests multiple building phases by different groups. An Ancient Origins article published December 2018 on earthquake evidence notes that pre-Inca cultures may have possessed geological knowledge more sophisticated than previously recognized, enabling them to select and work stone with properties that post-date groups hadn't mastered. If the Kilke, or an even earlier unknown culture, built the lower megalithic courses, where did they learn these techniques? And why did the knowledge apparently decline before the Inca arrived? The cultural continuity question remains unresolved. Precision. Then the theories fall apart. Modern engineering can hypothetically replicate the construction with cranes, computer modeling, diamond-tipped saws, surveying equipment. But strip those tools away and try it with stone hammers, rope, and empirical observation at 12,000 feet elevation. The gap between what should be possible and what exists gets uncomfortable. Archaeologist Alexei Vranich spent summer 2024 excavating at Sacsayhuamán with ground-penetrating radar, trenches at strategic points, and 50 years of comparative data from Tiwanaku in Bolivia. He told his followers the two biggest questions remain unanswered: how they moved the stones and how old the different sections truly are. His excavations in the Muyukmarca, Bastion bases, and Cruzmoco sectors aim to establish construction chronology. Results haven't been fully published yet, but the fact that after intensive work using advanced geophysical tools, a leading expert still calls these the biggest unanswered questions tells you everything. We haven't solved this. 20,000 workers over 70 to 90 years hauled stones from nearby quarries, shaped them with stone tools, fitted them by trial and error, and created what we see today through sheer determination and available labor. That explanation requires you to accept that transport, cutting precision, lack of failed attempts, earthquake resistance, astronomical alignments, and labor organization all worked at impossible levels using methods that barely replicate at small scale and controlled experiments. It requires you to believe they achieved first attempt perfection on 200-ton blocks. It requires you to ignore colonial accounts of plant-based stone softening. It requires you to dismiss vitrification evidence as natural geology without comprehensive testing. It requires you to accept that the Kilke built nothing significant despite 3 centuries of occupation before the Inca arrived. Maybe tunnels excavated in 2025 reveal inscriptions that explain everything. Or maybe Sacsayhuamán is exactly what it appears to be: construction that exceeds the technological capacity of its documented builders, executed with precision that shouldn't exist, surviving through engineering principles that required knowledge the Inca theoretically didn't possess. In the Cruzmoco sector behind the main walls, his team discovered evidence that Sacsayhuamán extended far beyond the visible walls. The area contains foundations of structures the Spanish demolished so completely that nothing remained above ground. Using laser scanning and historical field notes from Léonce Engrand in 1848 and Max Uhle in 1893, Vranich and his team are attempting digital reconstruction. What they're finding suggests Sacsayhuamán wasn't just a fortress. It was a complex ceremonial center, administrative hub, astronomical observatory, and engineering testing ground all in one. The scale rivals anything built by contemporary civilizations, and 40% of it is gone, broken apart by Spanish colonists who needed building material and were mining 5 centuries of accumulated engineering knowledge for limestone blocks. That's the final mystery nobody lists. How much evidence did we lose? The Spanish tore down the upper walls, the towers, the buildings. They filled in passages, sealed tunnels, hauled away thousands of precisely cut stones. Early archaeologists describe finding walls buried under meters of debris. Colonial Cusco is built from Sacsayhuamán's skeleton. Every church, every mansion, every colonial building in that city contains stones that once formed part of the complex. Those stones held information, tool marks, construction sequences, assembly evidence. Gone, used for door frames and foundation fill. When you visit Cusco today and see colonial architecture, you're looking at Sacsayhuamán's missing pieces. The evidence that could solve these 12 mysteries might be sitting inside a 16th century church wall where no one can examine it. Building material 400 years ago. Construction of this required surveying, ventilation planning, structural calculation, and execution at a scale that elevates the mystery rather than solving it. You don't build 8 kilometers of underground passages as an afterthought. That's intentional, sophisticated, purpose-built infrastructure. For what? Ceremony? Communication? Emergency routes? All 3? Excavations planned for March-April to 2025 might provide answers, but they might just add more questions. The astronomical alignments shouldn't achieve 3-degree accuracy without optical instruments. The labor organization shouldn't work at that scale without written management systems, but it all did. It exists. Walk up and put your hand on a 200-ton block fitted so tightly that you can't slide a knife blade into the joint. That's not legend. That's physical reality sitting on a hillside in Peru, defying explanation, surviving centuries, waiting for someone to figure out how 12 fundamental mysteries got solved 500 years ago by people who theoretically lacked the technology to solve even one. Explain how they exist. Maybe in another 500 years we'll understand how they got there. Or maybe Sacsayhuamán will remain exactly what it is right now. Undeniable proof that our understanding of ancient capability is incomplete, our theories of technological development are wrong, and sometimes the simplest explanation is the honest one. We don't know. These 12 mysteries remain unsolved because they are currently unsolvable with available evidence. That's not failure, that's the boundary of knowledge. And at Sacsayhuamán, the boundary is built from 200-ton stones fitted together by methods that might as well be magic.